Hello everyone, a warm welcome to my channel. I am Vidya. I am going to discuss the stream ciphers, which are one of the symmetric ciphers. The symmetric encryption algorithms are basically classified into two parts. One is called as the stream cipher, other is called as the block cipher. In this video, I shall be focusing on stream cipher. Coming to the block diagram of symmetric encryption, as we all know, whenever we want to send a secret message to the other end over an internet, we have to encrypt the message and then send it to the other end so that the attackers cannot read the message. There are two types of encryption algorithms. One is called as symmetric and other is asymmetric. I have discussed about the two methods in detail in the previous videos whose link is provided in the description box. However, in short, symmetric ciphers are those encryption algorithms which uses the same key at the encryption and the decryption end, while asymmetric ciphers are the ones which use a different key for encryption and a separate and different key for decryption. Now let us have a quick look at the encryption process. So the message, which is also known as plain text, is given to an encryption algorithm along with the key and is converted into a meaningless message known as ciphertext. Now here we are discussing those encryption algorithms which uses the same key at the encryption and the decryption end, which are known as symmetric encryption algorithms. Symmetric encryption algorithms are categorized into two types. One is called as the stream cipher and other is the block cipher. So what is the difference between a stream cipher and block cipher? In stream ciphers, the plain text is encrypted bit by bit or byte by byte. That is, it encrypts it one bit at a time or one byte at a time or one character at a time, while a block cipher encrypts the data in groups. So it processes the plain text as a chunk of bits. Now let us check the difference between stream cipher and block cipher with the help of example. Let us say we have stream cipher as well as a block cipher and we are giving the same plain text to both of them. When the stream cipher processes the plain text, it processes it bit by bit as follows. So the plain text arrives as bit and the ciphertext bit is generated at the output, while the block cipher takes the entire block of plain text, processes it at the same time and generates the entire block of ciphertext. I hope the difference between stream cipher and block cipher is clear. Let us now have a look at the mathematical expression of stream cipher. So a stream cipher basically processes the ith bit of the plain text using the ith bit of the ki and generates the ith bit of the ciphertext. Now, how does it do it? So, the ith bit of the ciphertext is generated by applying an encryption function on the ith bit of the plain text using the ith bit of the key. The general expression is written like this. However, what is the encryption function that is used by stream cipher? So the ciphertext is basically the addition function. So it adds the plain text bit with the bit of the key. Since we are operating on a binary values, we have to do mod 2 operation. So these are the expressions used by the stream cipher. Now why do we use modulus 2? So as I've discussed in my previous videos, mod n operation is basically used whenever you are working on finite fields, and most of the cryptographic algorithms works on finite field. So mod n ensures that whatever is the answer of pi plus ki results in a value which is always between 0 to n minus 1. So if we are doing mod 2, it ensures that your ciphertext bit will always be between 0 to 1. That is, we'll either have a 0 or we'll have a 1 as expected, as we are working on binary domain. So since we are using binary domain, we are using only two numbers, that is 0 and 1. So pi is either 0 or 1. The key is either 0 or 1. Similarly, the generated ciphertext is either 0 or 1. So since you are using binary values, which is either 0 or 1, we use mod 2 while doing addition. Now we shall see a very interesting thing here. Let us try to understand what is the result of the mod 2 operation. Let us fill up this table for different combinations of pi and ki. Since stream cipher processes the plain text bit by bit, pi can either be 0 or 1. Similarly, the ki bit can either be 0 or 1. So the total number of combinations will be 4. So it could be 0 0, it could be 0 1, it could be 1 0, or it could be 1 1. So if you do 0 plus 0 mod 2, results in 0 mod 2, which is 0. If you do 0 plus 1 mod 2, which is 1 mod 2, which is 1. 1 plus 0 mod 2 is 1 mod 2, which results in 1. Now 1 plus 1 mod 2 is basically 2 mod 2. What is the result of this? So in order to do all these modular operations, we require modular arithmetic, which I have discussed in my previous video. If you have not seen the video, I would request you to go through that video so that you understand how we get the results here. So 2 mod 2 results in answer 0. By doing a mod 2 addition, we got the following answer. Now have a look at these results that you have got. What does this result resemble to? When 0 is added with 0, we are getting 0. 0 when added with 1, we got 1. 1 plus 0, 1. 1 plus 1 results in 0. What does it look like? It basically represents a XOR operation. So when you do the XOR between Pi and Ki, you get the following outputs. Therefore, the equation of Ci can also be represented as Pi XOR Ki. Therefore, mod 2 addition basically is same as that of XOR operation, and hence here the expression for ciphertext can also be written as Pi XOR Ki. So these are the two ways in which you can write the expression for stream cipher. Let us now have a look at the block diagram of stream cipher for encryption. As all of you know, an encryption algorithm is used to process plain text using a key and generates the ciphertext. However, we are talking about stream ciphers now. So if it is a stream cipher processes the plain text bit by bit. So it takes the ith bit of the plain text and using the ith bit of the key, it generates the ith bit of the ciphertext. But what is the encryption algorithm that it uses? We have just seen in the previous slide. It generates the ciphertext using the encryption algorithm, which is the addition between the plain text and the key, and it does the addition using mod 2. Why it uses mod 2? Because we are working with bits, that is binary data, which is either 0 or 1. So there are two possible values, 0 or 1. Therefore, we are using mod 2. So as we just discussed, mod 2 operation also represents XOR logic gate operation. So Ci can also be generated using a XOR logic gate. That is, we do XOR operation between Pi and Ki. Therefore, how can I represent this in the form of a block diagram? I take the ith bit of plain text, give this ith bit to a XOR gate. The XOR gate also uses the key, which is the ith bit of the key, and generates the ith bit of the ciphertext. So this particular block diagram represents the block diagram for stream cipher encryption process. Similarly, let us see the decryption process. So for decryption, a decryption algorithm takes the ciphertext along with the key and generates the plain text. Since we are talking about a stream cipher decryption algorithm, the stream cipher decryption algorithm processes ciphertext bit by bit. So it takes the ith bit of the ciphertext, it uses the ith bit of the key and generates ith bit of the plain text. Now the question is, what is the stream cipher decryption algorithm? We get the output plain text by using a decryption function on the ciphertext using the key Ki. Now what is the decryption function that you are using? The decryption function is the addition between the ith bit of ciphertext and the ith bit of K mod 2. Now as I discussed, mod 2 can also be shown with the help of XOR logic gate. So we can recover our plain text using XOR operation between the ciphertext and the key Ki. So with this, we can represent this into a diagram, that is, stream cipher decryption algorithm takes the ith bit of the ciphertext, gives it to a XOR logic gate along with the ith bit of the key and generates the plain text Pi. So this particular diagram represents the stream cipher decryption algorithm. Let us now understand the encryption process with the help of an example. Let us say we want to encrypt letter A using stream cipher. So our plain text is now letter A. Based on the ASCII table, the binary equivalent of letter A is represented as, so our plain text bits are, now let us assume a key as 101. 1110. And we are doing a XOR operation to generate cipher text. As all of you know by now, to generate the cipher text, you have to do XOR operation between the plain text and the key. So we do a XOR operation between the plain text data and the key. So using the truth table of XOR, 1 XOR 0 is 1, 0 XOR 1 is 1, 0 XOR 0 is 0, 0 XOR 1 is 1, 0 XOR 1 is 1, 0 XOR 0 is 0, 1 XOR 1 is 0. So this is my cipher text that is generated. Okay. Now this cipher text is transmitted to the receiver end. The receiver receives the cipher text, and because it is symmetric encryption algorithm, it uses exactly the same key that was used for encryption, and the plain text is recovered using decryption algorithm, which is it uses XOR between the cipher text and the key. So we will again do XOR operation here, and let us see whether we recover our data back. What was our data? Our data was letter A, whose binary equivalent for the ASCII code is as written here. So cipher text is XORed with the key to recover the plain text. So 1 XOR 0 is 1, 1 XOR 1 is 0, 0 XOR 0 is 0, 1 XOR 1 is 0, 1 XOR 1 is 0, 0 XOR 0 is 0, 0 XOR 1 is 1. So the decryption result shows that you have successfully recovered the plain text P. Let us now check out on the advantages and limitations of the stream cipher. Because the stream cipher processes the data bit by bit, it does not have to wait for the bits to be accumulated and constructing a block which can be processed by a block cipher. It just receives a bit, processes it, and generates the output. Receives the other bit, processes it, and generates the output. And therefore, because of bit by bit processing, it results in high speed processing. Also, since the stream cipher processes the data bit by bit, if an attacker tries to alter one of the bit of the cipher text in the recovered plain text, only that particular bit will be affected, while the other bits will remain as it is. It won't be modified. So only the location at which the attacker has modified that particular location of the bit will be affected, because the processing is done bit by bit in case of stream ciphers. This results in low error propagation. That is, the error that is created in one of the bit of the cipher text is not propagated into the other bit. It is only restricted to that particular location, and it is not allowed to propagate into the other location. Now let us say the limitations of stream cipher. So stream ciphers, since they are based on XOR operation between the plain text and the key, and basically it processes bit by bit. So the bit value could either be 0 or 1. So it makes us very easy for an attacker to predict the key, and hence it has a limitation of less security. The second limitation is less diffusion. Now what is diffusion? Basically stream ciphers are not based upon changing the positions of the bit. It does not allow shuffling of the bits. So the bit locations in stream ciphers are fixed, and this makes it vulnerable to security attacks. Since the position of the bit in the cipher text and plain text is fixed, the attacker can easily modify some of the bits in the cipher text, and that affects those particular bit locations of the recovered plain text, and therefore changes the message that has been recovered. So overall, a stream cipher is faster, but it provides less security. Let us see some of the examples of stream cipher. Very simple example of stream cipher are the substitution ciphers such as scissor cipher, affine ciphers. However, the stream ciphers that we find in use today are as follows, and it is not a comprehensive list, so there are many more of them. I'll not discuss this in this video. These are just to provide you some examples. So with this, we come to an end of this video. Thank you guys for listening to my video. I hope this video has helped to you. Thank you. Take care. Stay blessed.